everybody, welcome back boys and girls. It's your main math man, Mr. Shane, coming to you live from Summit Academy. And in this video, we're still working on that unit number 4, but we're on lesson number 10 now. And we're going to be looking at some systems of equations. That just means that we're going to have multiple functions or multiple equations graphed out on the same coordinate plane. So in the first part, it says, which one doesn't belong? Lines in the plane. So I'd say first pause and work with your partner. Try to come up, pick one of these that you think does not belong, and make sure to write a sentence or at least an idea about why you think it does not belong. Underneath it, it says Jada told Noah that she has $2 worth of quarters and dimes in her pocket and 17 coins altogether. She asked him to guess how many each type of coin she has. So the part underneath of it is going to go with this table as well, but we'll do one part at a time. So it says here's a table that shows some combinations of quarters and squares. Quarters and squares. Quarters and dimes that are worth $2. So we're going to complete the table. So first we need to write the equation. So we're going to say the equation for this is going to be as follows. So first step, write the equation. So the equation that goes along with it, well, it says a quarter, which is going to be 0.25. We're going to say that's going to be the number of quarters is going to be x, and the number of dimes is going to be y. When we said how much is each dime, well, that'd be 0.1 times y. And we said that has to equal $2. So that equals 2. So now that we have our equation, all we have to do is substitute some values in for our variables. So that means if we plugged in 0 for x, that means that if we solve for y, we should have 20 dimes. So same idea with number of quarters. So I'm going to say, let me make some space over here. I'm going to say if I have 0, so this is plug in values to solve. So what I'm going to do is I'm going to replace one of these variables, x or y, and then I'm going to solve for the other variables. So for the first one, since it gives me, I have 4 quarters, so I have 0.25 times 4, because that's my x value, plus, and then I have 0.1y equals 2. So now I can just simplify, so this is going to be equal to 1 plus 0.1 times y equals 2. Make sure you can use your inverse operations to get y by itself. So I'm going to subtract 1 from both sides. And so this is going to be 0.1 y equals 1. Divide both sides by the coefficient, so divide both sides by 0.1. And I'm going to say that we have y equals 10. So the other value that goes along with it is going to be 10. And so what I can also do is I can check, let me write this down, let me say check using Desmos. So when you pull up your Desmos calculator, you can have your graph like this. I'm going to type in my equation. So I'm going to say if my equation is 0.25 times x plus 0.1y, that equals 2. So now I can say, okay, is the point, what was it, 4, it was the point 4 comma 10. Is the point 4 comma 10 on my graph? Well, I can find it out. Well, yes, it is. Since it is on the line, then I know it is a solution. That just means it works out for our equation. All right, so let's keep going. Let's try the next one. So it's now saying when y equals 0, what happens? So let's plug this in. So let me make a little break here. And so I'm going to say, all right, 0.25 times x, because we don't know what x is, but we have 0.1 times 0, because that's our y value. We're solving it when it's equal to 2. So now this is going to go away, because that's equal to 0. So we're going to have 0.25 times x equals 2. And then we just have one simple step to solve. So we're going to divide both sides by that coefficient. So we have 0.25, divide both sides. And we're going to say x equals, should be, is that 8? Yeah, it should be 8. So is the point 8, 0 on our graph? So let's find out. So let me show this again, and let me find, is the point 8, 0 on our graph? It certainly is. Notice how it's on the line. If it wasn't on the line, so for example, if I had like 8, 1, notice how that point is not on the line. So we need a point that is on the line exactly as it looks. So let me write that somewhere as well. So let me say points on the line are solutions. That just means it works out for that order pair. Okay, one last one for this. It says when y equals 5. So let's plug it in. So we have 0.25 times x plus 0.1 times 5, and use those parentheses to show multiplication. So I have 0.1 times 5 equals 2. So let's simplify. This is going to be 0.5. This comes down and stays the same. So 0.25 times x plus 0.5 is equal to 2. Two-step equation, I'm trying to get x by itself, so I'm going to subtract 0.5 from both sides. And so now I have 0.25 times x equals 1.5. Last step, divide by the coefficient, so divide both sides by 2.5, or sorry, 0.25, I should say. And so now I can say x equals, was that 6? Yeah. So now, is that order pair 6, 5 on our graph? Let's check. So let me graph this out. So is the point 6, 5 on our graph? It certainly is. Notice how it's on the line, so that way we know it is a solution. All right. And for the last one, what I'm going to do is I'm going to say, okay, now solve. So we're going to say pause for your turn. And what I'm going to say is, I will give you the x value. I will give you that the value for x is 2. I want you to solve for this y value. So when x equals 2, what is your y value? So make sure you can pause for your turn. You can ask questions as they come up. All right, underneath of it, it says here is the graph of the relationship between the number of coins, or sorry, the number of quarters and the number of dimes when there are 17 total coins. And it says, what does that point A represent? So find that point A on this line, and saying, well, I can say this. Well, find the ordered pair. So I'm going to say that's going to be 8, 9. So the point 8, 9 means 8 quarters and 9 dimes. And saying how much money in dollars is the combination represent? Well, we have each of those values, so we're going to say, well, it should be, let's do it underneath. So let's say it's going to be 8 times 0.25 plus, and then 9 times 0.1, which should equal 20, or no, not 20, it should equal $2.90. So again, we're saying with those values for each of those coins, how much should it be? So then it says for part 3, is it possible for Jada to have 4 quarters and 13 dimes in her pocket? And we can explain how we know. Well, even though it's tricky, because if I look, it says 4 and I would have 13. So the point is on that line, but we're talking about specifically Jada. So let me switch back to green. So since we're talking about Jada, we have to say no. So we say no, and we say even though we have 4 quarters and 13 dimes, that equals 17 coins. We have to say they do not add up to $2, because that's what we're trying to do. If you check the previous part of the question, we're trying to add up to $2. So now it's saying, okay, well, how many quarters and how many dimes does Jada have? Well, I kind of gave you a hint on that last one, because if you solve, solve your turn from before, because if you do that, then you should have the answer. So we should have, we can say this, so we can say, let me write this in, or I'm going to do it like this. So let's do part, there it is. So let's have, since 2 times 0.25 plus 15 times 0.1 is equal to $2. It is the only combination that is on the graph and the table. So if I look at the table, it should have 15 on here, but you have to solve that. And if we look at the graph, we're saying 2, 15, it's that point right here. So just be able to use the table and the graph to be able to solve for your answer. All right, on the next part, it says Claire and Andre are making signs for all the lockers as part of the decorations for the upcoming Spirit Week. Yesterday, Andre made 15 signs and Claire made 5 signs. Today, they need to make more signs. Each person's progression today is shown in the coordinate plane based on the lines. Mark the statement that is true or false for each person. And so what I'm going to say is this. I would say kind of figure out which person is which line. So I would say what I would do is this. I'm going to say Claire is the blue line. Claire is the blue line. And I'm going to say that Andre is the black line, which will be helpful because if you notice it says Claire made 5 signs and Andre made 15 signs. So using that information, I can say, hey, that's where they started at, and so those are going to be the starting points. All right. So let's find, it says for point A, at 40 minutes, I have 25 signs completed. So at 40 minutes, that point A, well, if I look, I notice, hey, point A is on both lines. So I can say, let me write that underneath. Point A is on both lines. So that means it's going to be true for Claire and true for Andre. Point B, at 75 minutes, they have 42 signs, or 42 and a half signs completed. So who's that true for? Well, it's true for Claire because it's on the blue line, but it's false for Andre because it's not on the black line. So we're going to say point B is only on blue line, which is Claire. Then for point C, what does it say? It says at 0 minutes, I have 15 signs completed. Well, what's that starting point? That's going to be false for Claire and true for Andre because it's point, let me say that point, what is that, C, is only on black line. And for the last one, at 100 minutes, so I have x equals 100, and I find that point D, I have 60 signs completed, so it's 100 comma 60. We're going to say that is false for both. So I'm going to say false for both. And that makes sense because point D is not on either line. And so since it's not on the line, it cannot work for either person. So that's just a real simple intro of the solutions that are part of the lines. So if it's on the line, it's a solution. If it's on both lines, like we have for point A, then it's a solution for both points. All right, so now on the back, some practice for it that we have. It says match the lines M and N to the statements they represent. So for first part, it says a set of points where the coordinates of each point has a sum of 2. And so we're going to say for this one, let me do in green, that way it's a little bit different. We're going to say the line that goes with it. So we have to say about lines, we're going to say line N is the one that has the points that add up to a sum of 2. And that makes sense because if we look at point A, this is, let me write in black here, this is the point A is -2, 4, which if I look at that sum of points, or the sum of those numbers, it's +2. If I look at this point, it's going to be 6 and -4. So this is 6, -4. And this point is 12, -10. So this is 12, -10. So notice how when I add the sum of those numbers together, let me change this one a little bit better. So this is 4, like that. Okay, when I add the sum of those two numbers, the sum is 2. So make sure you're just kind of using those points. And so that means that the only other line that we have for the second part is going to be line M, because it says the set of the points where the y-coordinate of each point is 10 less than the x-coordinate. So if we have that, the points should be like this. It should be x and x minus 10. So if we look at the points, let's kind of draw these out. So this point D is 2 and -8. So that matches up. Point B we already have. 6 minus 10 is -4, so that works out. And this point E is 13, 3. So each of those points match up with what we have. All right, now for number 2, it says match the labeled points on the graph. So now we're going for these points now. So we're going to say, all right, match the points on the graph to the statements that they have. So which of these has two numbers with a sum of 2? Well, that's the entire line N. So we're going to say it's going to be points. We're going to say points That's A, B, C, yeah. Points A, comma, B, and C. Then it says, for the second part, it says two numbers where the y-coordinate is 10 less than the x-coordinate. Well, that's just going to be the points on the line M. So we're going to say for line, let me actually do, we do in green to show that it goes with that line. So let's do this. So let's say points A, B, C. Now we can have same idea for this one. We're going to say points D, B, E. D, B, and E for line M. And then it says for the third part, I need two numbers with a sum of 2 and where it has the y-coordinate. So where do those two lines intersect? Well, that's only at the one point B. So we're going to say at point B is where they intersect right in the center. Notice how it kind of has the conditions for both line M and line M. It satisfies both conditions. So since it works out for both, we're going to say that's where we have that point. All right. For number 2, it says Mai earns $7 per hour mowing her neighbor's lawns, and she earned $14 for hauling away bags of recyclables. So write the equation to go along with it. So we're going to say M is equal to, we have 7H plus 14. So we have $7 per hour plus the 14 that she starts with for the recyclables. Then it says Priya babysits her neighbor's children. The table shows the amount of money M she earns in H hours. If it says Priya and Mai have agreed to go to the movies after they have earned the same amount of money for the same number of work hours. So that's our goal. If I look at Priya's equation, so this is Mai, we have Priya. Priya is going to be, let's say M, we're going to say money equals 8.4 times H. And so what we can do, it says how many hours do they have to work to go to the movies. So what I would suggest you do is this. Graph on Desmos. Make sure you can replace, instead of H we have X, instead of M we have Y. So what I can do is I can type in my two equations that I have for this situation. So I'm going to say in my graph I have Y equals 7X plus 14, and then my other equation is Y equals 8.4 times X. So now that I have my graph set out, it's saying how many hours do they have to work before they go to the movies. Well, they're looking for the same number of, or the same amount of money and the same amount of hours worked. So all I have to do is I have to drag, find where they are equal, and have that point. So notice how they intersect, and you can kind of click and drag and find that point on your two lines, but wherever they cross is where they are equal. And so they're equal at the point 10, 84. So let me write that down. So we're going to say like this. So they're equal at the point, let me write this down separately. So we have 10, 84. All right, so it says how much do they earn, or how many hours, so that's our X value. Well, that's just going to be 10, so 10 hours. How much do they earn? So since how much, that's going to be, or let me say earned, I guess. We'll say $84. And it's saying explain where the solution can be seen in the table, the graph, and the equation. So how can we see that? Well, let's write it like this. I'm going to say, let me type this out so that way it's easier to read. Let's do a little bit smaller. How about this one? Sure. So let me do, let's say, let me change this to orange, let's do. Okay, so let's say the table, we're saying where H and, like this, where H and M are in both tables. So we can find those two values when we're looking at the equation, or sorry, when we're looking at the graph. The graph, it's where the two lines intersect, which we know that point as H comma M. And for the equation, we set the two equations equal to each other and solve. So anytime we're trying to figure out, where these two equations are equal, that's three different ways that we can get it. So in the table, it's just that point H and M where it has the same point. On the graph, we just find where they intersect. That's at the point H comma M. And then for the equations, we can set the equations equal to each other and solve for one of the variables. And lastly, underneath of it, it says for each equation, explain what you could do first to each side of the equation so that there would be no fractions. So this is kind of like we're doing that one inverse operation for each of these equations. And if you want to, you can solve, but you don't need to. So let me write it like this. So I'm going to say, I give you a hint. You're going to multiply. For each of these, you're going to multiply by the least common multiple. And what I mean by that is if I look at these two numbers, what's the least common multiple? So I have to write multiples of 3 and multiples of 8, and I'd find that 24, so if I, for this one, I multiply, write it carefully, there we go. For this one, I'm multiply both sides by 24. For the next one, least common multiple of these two is going to be 12, so multiply both sides by 12. For the next one, I'm going to say, what's the least common multiple of 8 and 4? Well, that's already 8, so multiply by 8. And for the last one, I'll do an orange. Least common multiple of 15 and 6, a little tricky, but if you multiply by 30, you'll get what you want. So multiply by 30. So if you find yourself having extra time to try to solve these, please do. Maybe try graphing to solve. So let me write that. Try graphing to solve. That way you can get those answers very easily. Otherwise, be sure to ask questions. Make sure you pause for your turn. As always, super slam that subscribe button.